Namaskar, welcome to the channel Anka Ananda Aharan. Let us extract happiness from the teaching learning process of mathematics. Today we are going to solve some of the problems of article 2.2 and 2.3 of linear algebra and its application by Gilbert-Strang book. The purpose is to enable its viewers to solve the problems of the Gilbert-Strang book independently by their own. The question is, choose the number q. This question we are going to study. Choose the number q so that, if possible, the ranks are 1, 2 and 3. Observe, in case of B, rank 3 is not possible as it has only 2 rows. And in case of A, rank 3 is not possible because second row into minus 2 is first row. Second row multiplied with minus 2 is the first row. So they are scalar multiple of each other. That means this matrix is singular. As this is a singular matrix, it's one of the pivot is missing. Hence, it cannot be having full set of pivots. So in both cases, matrix A and in case of matrix B, rank 3 is not possible. So this option is not there. Next, we will go for what value of Q rank is 1 and for what value of Q it is of rank 2. Let us discuss. Let us write down the first matrix. A is equal to 6, 4, 2, minus 3, minus 2, 1, 9, 6, Q. So here, to make this element 0, what I will do? R2 plus half R1 stored in R2, this operation I will do. And to make this element 0, I will make R3 minus 3 by 2 R1 stored in R3. So after doing these two operations, my first row remains as it is, second row becomes 0 and third row becomes 0, 0, Q minus 3. Because first row is multiplied by half. That is, it is 3, 2, 1. Then it is multiplied by 3. So it is, I am getting Q minus 3. Now, it is not in echelon form. To make it in echelon form, we will have row interchange operation. Let us do this row interchange operation. So what we are getting? 6, 4, 2 into this matrix I got. Now, 6 is here a pivot. But if this Q minus 3 is equal to 0, then it will be having only one pivot. So rank is 1. That is, Q minus 3 is equal to 0 means Q is equal to 3 implies rank is equal to 1. And Q is not equal to 3 implies rank is equal to 2. This problem is over. Next, we will go to the matrix B. The given matrix is 3, 1, 3, Q, 2, Q. To make this Q 0, I will do this operation, that is R2 minus Q by 3 R1 stored in R2. Now, first row remains as it is, 3, 1, 3. Second row, this value, it is divided by 3 and multiplied with minus Q. So here I am getting minus Q. So Q minus Q is 0. Similarly, here also Q minus Q, this element also 0. And this is Q by 3 minus Q by 3. So 2 minus Q by 3 is the middle element. Now, if this middle element, that is 6 minus Q, after writing it, this is the new matrix after simplification. So here, if Q is equal to 6, this element vanishes. So this element vanishes means it is having only one pivot, so rank is 1. And if Q is not equal to 6, that means it is a non-zero element. As this is a non-zero element, so rank of the matrix is 2. So I hope there is no ambiguity regarding this question. And regarding rank 3, rank of B cannot be 3 because it has only 2 rows. And rank of A cannot be 3 because it has a pivot missing. Same thing is written here. Next question is, we have to verify whether the given conditions are true or false. Give the reason if true or counter example to show it is false. A square matrix has no free variables. Observe, it is a square matrix and it has one pivot, that means one free variable. So it is we got a counter example, and according to that counter example, it is false. Next, an invertible matrix has no free variable. Yes, it is true, because a matrix is invertible means it has full set of pivots. That means every column in it is a pivot column. That means every variable corresponds to every column is a pivot variable. That implies no free variable exists. So it is only written here. Next, third question is, an m by n matrix has no more than n pivots, pivot variables. Yes, number of pivot variables is rank of the matrix. So rank R is always less equal to minimum of m and n. So rank R of a matrix, which is equal to number of pivots in the echelon form of the matrix, it is always less than or equal to the minimum of m and n. So naturally rank cannot be more than number of columns, neither it can be more than number of rows. So it is also true, and this is also true. In the second case, what it is telling? It is not more than number of rows. Here it is writing number of columns. It is not more than number of columns. It is not more than number of rows. Yes, it is true. So next question is, this is an equation determines a plane in R cube. What is the matrix A in this equation? Matrix A in this equation is 1 minus 3 minus 1, that is, this is my A. Next question is, what are the free variables, or which are the free variables? So here first this is my pivot, so it is my pivot variable, it is free variable, it is free variable. That means y and z are the free variables. Second part of the question is over. Then find out the special solutions. For the special solutions, as these are free variables, this is a free variable, this is a free variable. Here first I will assign y with 1 and z with 0. Then I will assign y with 0 and z with 1. I will substitute these values. So first of all, y1, z0, that implies x is equal to 3. Next, y0, z1 implies x is equal to 1. So I got these two vectors. So these two vectors are the special solutions of the given matrix. Now here the second part of the question is, there is another part. What it is telling? Special solutions are 3, 1, 0 and what will be the other? 1, 0, 1. Two vectors we got. This is one of the vector and another vector is this one. Still some part of the question is left. The parallel plane disk contains a particular point 12, 0, 0. All points on the plane are having the following form. Let us go for it first of all. So in the last equation, the parallel, this is the augment matrix of the new equation, that is x minus 3y plus z is equal to a relative minus 1. X minus 3y minus z is equal to 12. This equation This is the augment matrix. Now it has only one pivot. That means other two variables are free variables. To find out xp, what we used to do? To find out xp, in the free variables we used to substitute 0, and pivot variable we used to substitute the RHS vector, this one. So here the pivot variable is x, and x value we will substitute 12, and y and z are free variables, there we will substitute 0 to get the xp. So xp plus xn, what is my xp? This is my xp. Now to write down xn, let me verify how they are named. So here, this is my special solution which I obtained by substituting y is equal to 1. So which variable I am assigning here? 1, y variable. So this vector I will multiply with y, and similarly this vector I will multiply with z. Okay, so let me do that to get my special, xn vector. So xn is equal to y into 310 plus z into 101. So I got my xn, I got my xp. So my complete solution is x is equal to, or unknown vector is equal to 12 plus 0, 1200 y into 310 plus z into 101. Now fill in the blanks. Here I will write 12, here we will write 3, here it is 1. I hope how we wrote the solutions, everything is clearly understood to the viewers. Next is decide the dependence independence of these three vectors. Our target is to write down these three vectors as rows of a matrix, that is 1, 3, 2, 2, 1, 3, 3, 2, 1. So I wrote these three vectors as a matrix. Suppose its name is A. Then I will convert it into in echelon form. After getting converted, so how to convert? First row is multiplied with the 2 and subtracted from second row. That is, this operation is done to get this resultant. Similarly, third row minus 3R1 stored in R3, that is R3 minus 3R1 stored in R3 gives me, this is 3 minus 3 0, it is 2 minus 9, it is minus 7, it is 1 minus 6, it is minus 5. So after, so this is my second pivot, this is my second pivot, so below it this element I have to make 0. To make this element 0, I will go for this operation. What is the operation here? R3 minus 7 by 5 R2 stored in R3. After doing that operation, we got 3 non-zero pivots. We got the echelon form where it is having 3 non-zero pivots. Hence, rank of the matrix is 3, which implies rank of the matrix is equal to number of vectors. Hence, the vectors are linearly independent. This is, so it is, the vectors are linearly independent as the matrix is having full set of pivots. Next question is second matrix. Here what happens? The last, so all the 3's are replaced by minus 3. So this is my given matrix, that is 1 minus 3 2, 2 1 minus 3 minus 3 2 1. This is my given matrix. Now what operation I will do? R2 minus 2 R1 stored in R2. So Okay, so R2 minus 2R1 is stored in R2, and the second operation what we will do, observe this is minus 3, so first row I will multiply with 3 and I will add it with R3. So R3 plus 3R1 is stored in R3. These two operations we will do. What we are getting? First row remains as it is, nothing to be done. Second row, it is 2 into 1. So 2 minus 2 into 1, so it is 0. Then 1 minus minus 2 into minus 3, that is 1 plus 6, it is 7. Then minus 3 minus 4, it is minus 7. So this row is over. Now minus 3 plus 3, 0. It is minus 9. 2 minus 9, minus 7. 1 plus 6, it is 7. So I got this matrix. Now in this matrix, what we have to do? Again, there is a second pivot element is 7, and to make element below it 0, what operation I should do? I should add R2 because this is my pivot. I must use to make this element 0. I want to make this element 0. So what should I do? R3 plus R2 is stored in R3. How I will do? So first two operations, just rows I have just copied. Third row is 0 plus 0, it is 0. Minus 7 plus 7, 0. Minus, 7 minus 7, 0. So that means only two non-zero pivots are there. So its rank is 2, but number of vectors are 3. Hence the vectors are linearly dependent. So linear dependency, independency we have studied. Simply speaking, any vectors are given, we will verify whether it is more than the dimension of the vector space or not. If number of vectors more than dimension of the vector space, then it will be always LD. If it is less or equal, then we have to write them in a matrix. We have to find out the rank of the matrix. If rank is less than the number of vectors, they are linearly dependent. If rank is equal to number of vectors, the vectors are linearly independent. Now there is another question. So here W1, W2, W3 are linearly independent vectors, so that the difference V1 is equal to W2 minus W3, V2 is equal to W1 minus W3, V3 is equal to W1 minus W2 are independent, and find a combination of that of the V's that gives 0. So what we will do? W1, W2, W3 are linearly independent. Now V1 is equal to W2 minus W3, V2 is equal to W1 minus W3, and V3 is equal to W1 minus W2. Now what is V2 minus V3? W1 minus W3 minus W1 plus W2. That means finally I am getting W2 minus W3, which is my V1. So what I got? V2 minus V3, V2 minus V3 is equal to V1, or I can write it as a linear combination format. V1 minus V2 plus V3 is equal to 0. So I got a non-trivial linear combination of V1, V2, V3, which can be equated to 0. Hence the vectors V1, V2, V3 are linearly dependent. This problem is over. So I hope it is understood to the viewers. Then we will discuss about the next question. In the next question, here W1, W2, W3 are linearly independent vectors. V1 is equal to V2 plus V3, W2 plus W3. V2 is equal to W1 plus W3 and V3 is equal to W1 plus W2. There it was minus symbol, now it is plus symbol. We are expected to prove that V1, V2, V3 are linearly independent. To do so, what we will do? Let V1, V2, V3 be linearly dependent. That means they let V1, V2, V3 be linearly dependent. Then their linear combinations are, that is C1 V1 plus C2 V2 and plus C3 V3 is equal to 0. Okay, so that implies, so just let us multiply. What is, let us substitute the value of V1, V2, V3, that is C1 into W2 plus W3 plus C2 into W1 plus W2 plus C3 into W1 plus W2 is equal to 0. Now let us take the common W1, that is C2 plus C3 into W1. Similarly, let us take the W2 common, that is C1 plus C2, C1 and W2, C1 plus C3. So C1 plus C3 is the coefficient of W2. Similarly, what about the W3? Its coefficient is, this is W3, but it is W3. It is C2 plus C1 plus C2. This is equal to 0. Here W1, W2, W3 are three linearly independent vectors. That means their coefficients must be 0. That is C2 plus C3 is equal to 0. C1 plus C2 is equal to 0. C1 plus C3 is equal to 0. It is C1 plus C2 is equal to 0. Now from this second equation, it is equation 1, equation 2, equation 3. Now let us subtract equation 3 minus equation 2. How much we are getting? C2 minus C3, because C1 cancels each other. This is equal to 0. It is equation 4. C2 minus C3 is equal to 0. Here C2 plus C3 is equal to 0. So from 1 and 4, 2C2 is equal to 0. This implies C2 is equal to 0. Once C2 is equal to 0, that implies C1 is equal to 0 from this equation 4. And once C1 is equal to 0, then C3 is equal to 0, then C1 will be also 0 from equation 2. So finally we got that C1, C2, C3 all are simultaneously 0. So the linear combination C1V1 plus C2V2 plus C3V3 is equal to 0 leads to C10, C20, C30. That implies V1, V2, V3 are linearly independent, hence proved. Next, we will discuss about this question. Suppose V1, V2, V3, V4 are vectors in R cube. These four vectors are dependent because four vectors can, dimension of R cube is equal to 3. So here four vectors cannot be linearly independent. More than dimension number of vectors cannot be linearly independent. Hence it is, as dimension of R cube is equal to 3, maximum 3 vectors can be linearly independent in R square. Hence 4 vector cannot be linearly independent. Next question is, Two vectors v1 and v2 are dependent if they are scalar multiple of each other. It is if they are scalar multiple of each other. If they are scalar multiplication of each other. Multiplication 9. It should be proper word is if they are scalar multiple of each other. Next, the vectors v1 and origin vector are dependent because if suppose this origin vector is v2. Now my c1 0 into v1 plus any vectors, any value scalar c2 into v2 is equal to always 0. So I got a non-trivial, here it is 0 but this is non-zero. So I got a non-trivial linear combination of v1 and origin which gives me 0 vector. Hence v1 and origin are linearly dependent. Any vector with the origin is always linearly dependent. Next question is, find two independent vectors on the plane x plus 2y minus 3z minus t is equal to 0 in R cube. First of all, two vectors. Then find three linearly independent vectors. Y net 4 and the plane is, this plane is the null space of what matrix? First of all, let us find out. So here what it is giving? This is the given space or given vector space in R4. So what is the matrix? The corresponding matrix is 1, 2, minus 3, minus 1. So here this is the only pivot element, that is x is the only pivot variable. Rest all three variables are free variable. So in first I will assign y as 1, baki do 0. Now z is equal to 1, rest 2 are zeros. Now t is equal to 1, rest 2 are 0. So likewise I will assign these values to the corresponding three variables. Now I will find out the value of x from this equation. How much it is? When y is equal to 1 and z and t are 0, it is minus 2. And when z is equal to 1, baki rest two variables are 0, it is plus 3. And when t is equal to 1 and rest two free variables are 0, it is 1. So I got my x values. That means I got my three vectors, complete vectors, which will constitute my basis. Why they constitute a basis? Observe here. There are three vectors only. So first vector, second vector, third vector. That means maximum rank of the matrix containing these three vectors as its rows or columns is 3. But this matrix will have a submatrix of identity matrix of 3 cross 3 whose rank is 3. Hence the matrix will have at least rank 3, at most rank 3, that is the matrix has rank 3. So 3 vectors having rank 3, that means the vectors are linearly independent. Now, so this vector B, they are linearly independent because the rank of the matrix having these vectors as a row vector is equal to 3. Next part of the matrix is an arbitrary vector V is free variable t, free variable z and free variable y, and from this equation let us calculate the value of x. What it is? It is t minus 3z, t plus 3z minus 2y. So now this arbitrary vector can be obtained from the three basis vectors. What are these three vectors? Let these three vectors be named as E1, E2, E3. So here second component is having 1. That means second variable I will multiply to this. And here my third variable I will multiply to this. In this vector third variable, and in this vector fourth variable. That is my general vector. How we will write? So this is equal to, where is that? Hence second variable into E1, third variable into E2, fourth variable into E3. Whenever we will substitute the values of E1, E2, E3, we will get V is equal to this much. This vector, orbital vector V, is equal to the span of these three vectors. That means every vector of V can be obtained from the span of E1, E2, E3. That is, B is linearly independent and the span of B is equal to V, hence B is a basis for V. That implies as B has 3 number of vectors, dimension of V is 3. As dimension of V is 3, no vectors more than 3 number of vectors cannot be linearly independent. They will be always linearly dependent. Hence, 4 vectors in V or any more than 3 vectors in V cannot be linearly independent vector. So here 4 vectors were considered.